Hi, welcome back. So today we are going to talk about, continue to talk about respiratory system. Now, so these are the learning outcomes that we are going to achieve at the end of this class. Then number one, state the respiratory structures in human and some animals. And we are going to look at what are the animals. And then number two, to make an inference on the various adaptations of respiratory structures. So we need to at least state the adaptations of the respiratory surface structures in human and in some animals. Number three, describe the characteristic of respiratory surfaces in human and other organisms. So what are the characteristics that enable the surfaces to be able to supply sufficient amount of oxygen to the organisms, as well as to remove the carbon dioxide quickly to sustain life. Then number four, to describe the breathing mechanisms in human and other organisms. How do we breathe? Do you breathe with nose or do you breathe with mouth? Basically, we don't breathe with nose or mouth. Okay, so how do we breathe? We are going to talk about that later on in our lesson today. Then lastly, to compare and contrast the human respiratory system with that of other organisms. So the learning outcomes are actually very important because they set as the template for the examiners to come up with exam questions. So you based on these learning outcomes, you might expect that there might be questions asking you to compare and contrast a human respiratory system to other organisms. So if you have mastered this learning outcome at the end of this lesson, then well done, you are able to score in that questions. So let's proceed. So likewise, these are the four phases that we are going to go through today. So the first phase is the Y phase. Now we know that in our lungs we have millions of alveoli. But can't we breathe with the skin just like frog? Why do we need alveoli? So what are so special about alveoli? Then number two, why the thorax moves up and down when you breathe? Okay, then number three, why your abdomen, the abdomen moves up and down when we breathe? Now, so perhaps this frog, the Italian tree frog, might give you some hints on how we breathe. Now, so why this part? This is the floor of the buccal cavity. The buccal cavity is also known as the mouth cavity of the frog. Now, so why this floor, the floor of the buccal cavity moves up and down when it breathes? Okay, does it make it any prettier or sexier? We do not know, but it has to do with breathing. Okay, so let's look at the second phase. Okay, to answer the Y phase, the question set in the Y phase, so we need to look at the what phase. Now, so first of all, let's talk about the adaptations of the respiratory surfaces first. Now, so now to give you some idea. So basically, in most organisms, the respiratory surfaces are adapted to have a high total surface area. How? By increasing the number of the surfaces. Just like us, we have millions of alveoli, and then the inner surface of the alveoli, for example, is moist so that the gases can dissolve in the moisture. Number three, the membrane of the surfaces must also be 1 cell thick. Otherwise, the diffusion of gases might not be easy. Then number four, this is certainly true. True with most organisms, but not insects, because in insects they transport oxygen and CO2 with tracheal system. So basically, the blood doesn't transport gases. Now, so in humans, for example, the alveoli are surrounded by a lot of blood capillaries just to transport oxygen quickly away from the alveoli and to transport CO2 quickly enough to the alveoli. Now, so these are the the respiratory surfaces, okay, in humans as well and in other organisms. Like in amoeba has small size, so that's why they do not need to have a specialized system to help them to breathe. So basically they just breathe using their plasma membrane. Human being, on the other hand, is a multicellular organism. So in order to supply enough oxygen to billions of cells in our body, we need a large surface area. How do we do that? By having a large number of alveoli. And then in insects, the respiratory surfaces, okay, so the respiratory surfaces are the surfaces where the gaseous exchange occurs. So it takes place at the tracheals. In fish, it will be the filaments and the lamella. Alright, so where are they? They are found inside the gills. Okay, we are going to have a look later on. In frogs, basically they use the lungs, okay, the lungs to breathe, as well as the skin. And as well as the skin. Now, let's move on. So what are the adaptations of the respiratory surfaces in amoeba? Now, if you look at amoeba, now amoeba is small, so that's why the total surface area over volume ratio is very, very high. So basically it suggests that, okay, it has more total surface area as compared to its volume. Alright, we on the other hand, we are multicellular organisms. We have low TSA over V ratio, so that's why we need system, and amoeba do not need system, respiratory system, to help them to breathe. So basically the oxygen and CO2 diffuse across the plasma membrane by simple diffusion, so they are able to sustain this way. Then what about insects, for example? Now if you look at insects, now this is a housefly. Now this is the head, and this part is the thorax. Now inside the thorax there is actually the heart. Okay, the heart is here, but the heart is part of the blood circulatory system. It has nothing to do with the respiratory systems. Now, so where is the respiratory systems in insects? Now look at it. This is the abdomen. We will be able to find the tracheal system here. Tracheal system in insect. So this is a system that transports gases in it. So along the wall of the abdomen, we will be able to find multiple pores, and these pores are known as spiracles. Now, so as you can see here, let this one be the wall of the abdomen. So here we will be able to find pores. Okay, pores. There are multiple pores here, and each pore is actually the opening to a system known as tracheal system. Now, so what are they? Let's move on. Now, let this one be the wall of the abdomen, and this is a spiracle, and normally there will be valves here. Yeah, in case they were submerged in water, they are able to close the spiracle, preventing the water from oozing in the tracheal system. And then going in, okay, this tube is known as trachea. Okay, so if it is plural, so it is tracheal, and the wall, the trachea, is actually strengthened with rings of chitin. Now, so the chitin serve as the cartilage along our trachea, which is to prevent the trachea from collapsing during the breathing process. Now, the air will then be transported, okay, into the abdomen, and the trachea branches out to form many tiny tubes known as tracheals, and each tracheal will transport gases directly to the body cells. Now, so let's recall. So this is the direction of the movement of air. So it starts with spiracle, followed by tracheal, followed by tracheals, and each tracheal actually deliver the gases to the body cells directly. So what are the adaptations in insects tracheal system? Number one, the tracheals are actually, the membrane of the tracheals is actually one cell thick, so that the gases can diffuse across the tracheals easily. Okay, so CO2 can diffuse easily into tracheals, and the oxygen can diffuse easily from tracheals into body cells. And then number two, the inner wall of the tracheals is actually moist, so that gases can dissolve in the moisture before diffusing across the tracheal. So now this is the Carper word, okay, the Carper word. Now what do you mean by Carper word here? When we talk about moisture or moist, we have to write dissolve. We have to mention gases can dissolve easily. So these two will come together in examination. And number three, you see a lot of branches here. So tracheals actually come in large number. They are numerous, so that the total surface area for gaseous exchange is high. And then number four, the tracheals are in direct contact with the body cells, so that oxygen can be transported directly to the body cells. Now in certain insects, okay, large insects like grasshoppers, we will be able to find some air sacs. This is air sac along the trachea. Now, so what is the use of air sac here? It is to speed up the movement of air in trachea. So during the contraction of abdomen, the abdominal muscles, so air sacs will be compressed, as such it will deflate and then inflate again. So during the deflation and the inflation process, the air sac can help the air to move faster in and out along the trachea. Alright, now so we will be able to find air sacs, okay, again in large insects, okay, such as grasshopper, because during flying process definitely they need a lot of oxygen to be given to the body cells, so that cellular respiration can take place. Okay, now next part. Oh yeah, before I forget, now this is a very cute tiny creature, and it's dragonfly, or we say damselfly. Now if you look at it, this is the head, this part would be the thorax, and the abdomen is actually quite long. And if you look at it carefully, you will be able to find a lot of spiracles here, and these are the breathing pores for this insect. So if, let's say, if you want to, now of course, okay, this example is not so well, okay, I don't want you to torture the animals, but let's say if this animal, okay, was submerged in water, the head is left outside the surface of the water, but the abdomen is left in the water. So guess what might happen to this insect? It will be drowned. Alright, simply because it breathes with the pores in the abdomen. Okay, so we have discussed about amoeba and insects. Now let's move on to fish. So I'm sure, okay, we all, unless you were vegetarian, okay, else you might have the experience, okay, of eating fish. Now this is a fish head, and if you remove this protective covering, okay, known as operculum, you will be able to see the gills. And normally the gills are processed, okay, are removed before the fish, okay, is prepared, okay, to become your dishes. Now, so there are actually, okay, in bony fish, the fish that have bones, okay, and they have 4 pairs of gills, okay, 4 on each side. Now, so if you pull out one of the gills, okay, this is what you are going to see. Now, this part is actually bone, okay, bone, and it is known as gill arch. And along on the surface of the gill arch, we'll be able to find some sharp, tiny structures known as gill raker. Alright, and then attached to the gill arch is the filament. So this thin sheet, okay, of structure, normally red in color or dark red in color, is the gill filaments. Now, so basically gill filaments, okay, look something like this, okay, look something like this. They are just flat, if you look at it, okay, in a, using microscope perhaps, okay, you will be able to find some tiny structures, okay, which protrude out of the surface of filament, and these are known as the lamellae. Lamella singular, lamellae plural. Okay, now what is the use of lamellae? Now it is just like the villi in our small intestine. Now, so the function is to increase, okay, to further increase the total surface area of the respiratory surfaces, so that gaseous exchange can occur quickly. Now, what will happen, okay, if you try to look at it from this point, okay, from this perspective, now you will discover that, okay, now this is a gill raker, this is a gill arch. Now, inside the gill arch, we'll be able to find a lot of blood capillaries, and then actually the filament, okay, the filament is actually made of two thin sheets of structure, and then on the filament, we'll be able to see tiny projections or protrusions, okay, known as lamellae. Now let's talk about it. Now, what are the adaptations of respiratory surfaces in fish? Number one, the filaments and the lamellae are one cell thick, so that the gaseous diffusion can occur easily. Then number two, definitely must be moist. Okay, if there's no moisture, there's no flow of water, basically the gills will just, okay, the filaments will just, okay, stick to each other, reducing the total surface area for gaseous exchange. So that's why the fish needs to have water flow to breathe, else the filaments will all be sticking together. Okay, then number three, fish does have gills. In the gills, okay, we find filaments and lamellae. So they are numerous. You have numerous lamellae to increase the total surface area for gaseous exchange. And then number four, actually the gills is rich in blood vessels. Okay, it is shown here. So basically you will be able to see blood vessels or blood capillaries running through the filaments. Now, so why the filaments have to be supplied with a lot of blood capillaries, so that oxygen can be transported quickly to the body cell. Now, so on top of these four, there is another adaptations here, okay, that worth to take note. Now, the efficiency of gaseous exchange in fish, okay, can be further enhanced by the counter current exchange mechanism. Now, this is actually a specific term here, counter current exchange mechanism. Now, so in this mechanism, basically the direction of the blood flow in the blood capillary has to be opposite to the direction of the water flow. Now, so let this one, now look at it, let this one be the direction of the water flow. All right, and this must be the vein. Okay, it comes from the vein, and then this one, it goes to the artery. All right, so the veins transport the oxygenated blood, and then the artery transport the oxygenated blood away to the body cells. So of course, if you want to find, okay, if you want to know more about, okay, how counter current exchange mechanism is able to enhance the gaseous exchange, now I welcome you, go to search in the internet and then share in the class. Okay, then number four is about frogs, okay, the frog's respiratory system. So they are just like you see, just like human being, yeah, because they have lungs. But unlike humans, they do not have alveoli. But inside the lungs, okay, basically we find a lot of partitions. Now this is the lung, and we find small rooms here. Now, so this is partition number 1, partition number 2, partition number 3. So what is the use of partitions? Is to increase the total surface area for the gaseous exchange to take place. Alright. And then number 2, of course, the wall has to be one cell thick and moist. One cell thick to facilitate the efficient diffusion of respiratory gases in and out rapidly. And then the lungs, okay, are also supplied with a lot of blood capillaries to transport the oxygen to the body cells quickly, and to transport the CO2 to the skin and the lungs for excretion. And then since they do not have a very large surface area, okay, of respiratory surfaces, okay, as in human being. And that's why frogs need to breathe using skin as well. The skin has to be moist, and then the skin is also supplied with a rich network of blood capillaries, and the skin is actually thin, okay, even though it's not one-celtic, but it is thin enough, okay, and highly permeable enough to allow the oxygen to diffuse into the blood capillaries beneath the skin. Now, having said so, let's look at human being. Now, human being, okay, humans have a very advanced respiratory surfaces. Okay, now, like for example, we have millions, okay, millions of alveoli in our lungs. So if you cut, now look at it, what are alveoli? Now these are the alveoli. Now, so this is the trachea, then we have the bronchus, bronchiole, and finally the bronchiole ends with alveoli. And as you can see here, the membrane of the alveoli is only one cell thick, and the alveoli is also supplied with a lot of blood capillaries, and the inner wall is actually moist. Alright, so if you cut the alveoli and make them flat, paste on piece of paper. Now basically, guess what is the total surface area covered by all our alveoli? Now, so according to some research in the internet, okay, it might cover the total surface area of our alveoli is as big as 1 to 2 tennis courts. Now, so it doesn't surprise us, because if we do not have such a large surface, respiratory surfaces for exchange of gases, how can we sustain billions of cells in our body? Now, that's not possible. So what are the adaptations here? Number one, we have a lot of them. Increase total surface area, more gaseous exchange. Wall is one cell thick. Don't say thick, okay, we don't say thin or what, okay, we say it's one cell thick to facilitate the diffusion of gases. Then number three, it must be moist so that more gases can dissolve in the moisture. Then number four, surrounded by blood capillaries, again, to speed up the diffusion of gases, to transport the gases quickly away or to the alveoli. Now, so this is another diagram just showing the relationship between, or the proximity, okay, how close the alveolus is to the blood capillary. Now the blood capillary is also one cell thick, and the wall of the alveolus is also one cell thick. So that's why gaseous exchange can take place easily, okay, based on the concentration gradient. And then this is another view of our alveolar sac. Okay, so it was extracted from the Wikipedia. As you can see here, now these are actually the alveolus, and then these are the walls of the alveolus, which allows the diffusion of gases to take place. So if we smoke, actually, if we were a chain smoker, we actually breathe in a lot of acidic gases, because one of the main gases in cigarette smokes will be SO2 and NO2, sulfur dioxide and nitrogen dioxide. And when dissolved in the moisture in the alveoli or alveolus, so the gases form acidic solution, and the acidic solution is going to corrode away all this wall, so making this part empty. So without the walls, basically the total surface area for gaseous exchange is much reduced, and it might cause SOB. Now what is SOB? SOB is short of breaths. Alright, so if you don't want to suffer from that, okay, please stay away, refrain from smoking. Alright, now so let's take a short break first, okay, before we come back and look at breathing mechanism. Okay, so before I stop, perhaps, okay, it is useful, okay, to look at what we have learned so far. Okay, we have learned that, okay, the respiratory surfaces are adapted to, number one, to increase the total surface area for gaseous exchange. It must be moist, it must be one cell thick. Alright, and then if it's smoke, basically the heat the heat from the smoke might cause, might dry the moisture in the lungs, in the alveoli, so it might cause SOB as well. Alright, the wall must be one cell thick, and finally it is surrounded by a lot of blood capillaries. But this one doesn't apply to insects, because insect respiratory system, which is the tracheal system, does not transport gases. Alright, now so we take a break, then only we come back by looking at the third and the fourth phase. Alright, see you.